Okay, quickly let's take our calculations. Example 7.1. Find the turns ratio in a transformer which delivers a voltage of 120 volts in the secondary coil from a primary voltage of 60 volts. Don't forget the formula for turns ratio is number of turns in the secondary coil over number of turns in the primary coil. Since the number of turns are not given to us, we know that formula is equal to that formula is equal to the voltage in the secondary coil over the voltage in the primary coil. So all we need to do is to equate the number of turns to the number of turns ratio to the voltage ratio. And that's what we did. ES over EP equals to NS over MP. When we equate that, 120 over 60, that gives us 2. So what does that tell us? It tells us that the kind of transformer we have is a step-up transformer because the value of the turns ratio is more than 1. Example 2 quickly. 7.2. A transformer has 500 turns in the primary coil and 300 turns in the secondary coil. If the primary coil is connected to a 220 volt mains, what voltage can be obtained from the secondary coil and what type of transformer is this? Alright, so still using the formula, a number of turns in the secondary over number of turns in the primary equals to the voltage in the secondary over the voltage in the primary. So all we need to do, since we're given the number of turns in the primary and secondary and we're given the primary voltage, which is 220 volts, we just make the secondary voltage subject to the formula and we got 132 volts. Now what kind of transformer is this? If you check, the primary voltage is 220 and the secondary voltage is 132. So when the primary voltage is higher than the secondary voltage, what does that tell you? It tells you two things. Number one, it tells you that should be a step down transformer. When the primary voltage is bigger than the secondary voltage, it tells us that should be a step down transformer, meaning that the secondary voltage has been stepped down and its value has been reduced compared to the primary voltage. That is step down transformer. And also another thing we can see, if you look at the turns ratio, 300 over 500, you're going to be having 0.6. And since the turns ratio is less than 1, that's another proof that it is a step down transformer. In the previous example, it was greater than 1, and that was a step up transformer. The third example, they said draw a Liebert diagram to explain the working of a transformer, okay? Which can produce 24 volts from a 240 volt supply. And then the B part, if the efficiency of the transformer is 80% and the current in the secondary is 10 amps, calculate the current in the 240 volt supply. And the last one, this is a why question. Give two reasons which explains why the efficiency of a transformer cannot be 100%. Okay, so let's say the first one. Now before you draw the diagram, you have to calculate, okay, the turns ratio. So you can use the formula we use in example 7.1, number of turns in the secondary over number of turns in the primary, which is the turns ratio, equal to the voltage in the secondary over the voltage in the primary. But since we're just dealing with only the turns ratio, so we have number of turns in the secondary over number of turns in the primary, and that should give us 24 over 240, and that is 1 over 10, which is 0.1, and that is a step down transformer. So it says in the diagram, there should be more turns in the primary than the secondary coil, because they said the question is, we should explain the working of a transformer which can produce 224 volts from 240 volt supply. That means the primary is 240 and the secondary is 24. So that means the voltage in the secondary is low. So the only way to increase the secondary voltage is to increase the number of turns in the primary than the number of turns in the secondary, because if you invert it, you are going to have 10. You are going to have 10. You are going to have 10. So that's the diagram below. You can see that number of turns in the secondary is 20. The number of turns in the primary is 2 reverse. So it says in the diagram there should be more turns in the primary than in the secondary. That's the way you can get a step up transformer, because in the step up transformer the voltage in the secondary is higher than the voltage in the primary. Voltage in the secondary is higher than the voltage in the primary. So what the question is actually talking about is how we can step up the transformer. What is the condition needed? Or we should draw a step up transformer. Because to produce 24 from 240 volt is quite low, so the only option is to step up the transformer, and the only way we can do it is to increase the number of turns in the primary coil. And we'll do that. The only way to do that rather is to increase the number of turns in the primary coil than in the secondary coil. We'll do that. We're going to have a positive number. If you observe, initially what we had was 0.1, which is a step-up transformer. But the question wants us to transform it to a step-down transformer. So the only way to do that is to increase the number of turns in the primary coil.